Okay, let's talk about one of the coolest but also one of the most misunderstood ideas in all of physics. I'm talking about the observer effect. I'm sure you've heard this idea before, right? It's everywhere. You see it in sci-fi movies, you read about it in self-help books.
The idea that just by watching something, you can literally change reality.
The story usually goes something like this. These tiny little particles, they act one way when nobody's looking. But the moment a person, a conscious human being, watches them, they completely change their behavior. The big implication here is that our consciousness itself is actually bending the physical world.
I mean, that sounds incredibly deep, right? Almost magical. But, and this is a big but, that's not what physics actually says. Not even close.
So, let's get into it. Where did this whole reality-bending idea even come from? We're going to unpack the myth of the conscious observer.
You know, the crazy thing is, this whole massive confusion, it really just boils down to one single misleading word, observer. When we hear that word, we immediately think of a person, right? With eyes and a brain. But in the world of physics, it means something totally different.
Okay, so this is where it all gets mixed up. In our day-to-day lives, an observer is, well, a person. It's about consciousness, it's about awareness. But in physics, an observer could be anything. It could be a camera, a particle detector, basically any tool that measures something. It doesn't have a mind. All it has to do is physically interact with whatever it's measuring.
So for a physicist, an observation is just a physical interaction that gives you some information. That's it. And the observer is just the thing that does the interacting. No consciousness needed whatsoever.
And this, right here, this is the absolute core of the whole thing. See, at that tiny, tiny quantum level, you can't get information for free. To measure anything, you have to physically interact with it. You literally have to touch it in some way. Let me give you an example. Let's say you want to observe if a piece of wood can burn. How do you find out? Well, you have to light it on fire, right? The very act of measuring, of observing its burnability, destroys the wood. Your measurement was a physical, and in this case, a destructive act. Okay, but what about something less dramatic? Let's observe if that same piece of wood floats. We drop it in water, hey, it floats, and the wood is still there. But is it exactly the same? No, it's wet now. Its property of dryness is gone. So even that gentle observation was still a physical interaction that changed the thing we were looking at.
And this brings us to a line that just perfectly sums it all up. In that famous double-slit experiment, you know the one? When scientists stick a detector in there to see which slit the particle goes through, the whole pattern changes. And why? It's not because a person is suddenly watching. It's because putting a detector there physically changes the experiment. The setup is different, so of course the result is different.
Check out this example. Imagine you're trying to find out where a particle is using this funky-looking ruler. The ruler itself has an electric charge, and it literally yanks the particle into one of its little grooves. So think about that. The measurement isn't just finding the particle's position, it's creating it by forcing the particle to be in a certain spot. The observation itself is part of the action. Now, it's pretty easy to see how people get this mixed up because there is a real observer effect that involves consciousness, but it has nothing to do with physics. It's from the world of psychology, and telling these two apart is absolutely key.
It's called the Hawthorne effect. And it's something we've all experienced, right? It's when people, workers in a factory, students in a classroom, change their behavior just because they know someone's watching them.
Yeah, the British Medical Journal says it perfectly. People might change their behavior simply because of the attention they're getting. It's a totally psychological thing. It's about being self-aware.
But here's the absolute most important takeaway from all of this.
Particles aren't people. An electron doesn't know it's being watched. It doesn't think. It doesn't get shy or try to show off. It changes its path because something physical, a detector, got in its way. The change is because of interaction, not awareness.
So you might be wondering, if it's really that simple, why is this misunderstanding so common? Well, it all comes back to a really unfortunate choice of words. That word, observer, it's just loaded. It makes us think of eyeballs and brains. Honestly, if the scientists who first described this stuff had used a word like interactor or just detector, this whole myth probably wouldn't even exist. The words we choose really matter.
So, does taking consciousness out of the picture make quantum physics any less amazing? No way. In fact, I think the truth is way more incredible than the myth.
The real mind-blowing idea here isn't that our thoughts create reality. It's that information has a physical cost. You can't learn something about the universe at these tiny scales without physically poking it. And that poke, that interaction, always changes the very thing you're trying to look at. And that's not just some philosophical idea. It's a core principle of how the universe works.
So, in the end, reality isn't something we just passively watch from a distance. We're in it. We're part of the system. And every time we try to measure it or learn about it, we're interacting with it. And that interaction changes things.
Physics isn't mysterious because it's magic. It's mysterious because it's subtle. The observer effect doesn't show us the power of consciousness. It shows us a much deeper truth. You can't be a spectator of the universe. To observe is to participate. And to me, that's an even more incredible thought.